How are you?
Good, how
Good.
are you?
My name is Jagbir Singh. Today I am going to present small building design in New Zealand. First of all, I want to ask one question from all you have. That why you choose this construction management course? Is this related to your previous study or you are interested in construction?
I'm interested in construction, that's why I chose.
Yeah, very good. Now let's start with the introduction. Uh, Designing small building in New Zealand involves creating structures that are well suited to the country's unique environment, culture, and regulation. New Zealand diverse landscape ranging from coastal areas to mountain region influence building and potentially natural disaster like earthquakes and the culture value of the community. So let's move to the another slide. Uh, Functionality and user needs. There are the 4 points that I have mentioned in this slide. First one is space optimization. The second one is the accessibility. The third one is the storage solutions. And the fourth one is natural light and ventilation. Let's explain. First one, space optimization. Maximizing usable space with clever layout and built-in furniture. The second point is accessibility, ensuring easy movement within the house for all residents. And the third point is storage solution, maximizing storage capacity with clever built-in solutions. The fourth point is natural light and ventilation, creating a bright and airy living environment. Let's move to next slide. Sustainability consideration. Energy efficiency. First point is energy efficiency. Passive solar design, insulation, and efficient appliances are applied in the building, so which help in energy efficiency. The second one is the water conservation. Rainwater harvesting and water efficient features. As you can see in this picture, we all have to conserve water in our daily life routine. And the third one is material selection, sustainable and local source material. Let's move to next slide. Material selection and impact. When we make the small buildings and design, first we have to select the material. Like basically in New Zealand, these four material is used in making the buildings. First one is timber, stone, and the timber is renewable and low abundant energy. The second one is stone. It's very durable and natural insulating. Third point is recycled material, which is used by recycle the waste material and reduce waste, lower environment footprint. It is the advantage of recycled materials. Let's move to next slide, the time and cost implementation. The first one is time implication. First point, project timeline. How long will the project or task take to complete in the making the building? And the second one is delay and deadlines. What are the potential delay that could occur and how might they affect the overall timeline? The third one is resource allocation. How much time need to be allocated to each task or resource to ensure timeline completion? The second one is cost implication. From very first point is budget. What is the estimated cost of the project or decision? This is the main point in the both cost implication. We need to first maintain our budget and then we start. The second point is cost overruns. What are the potential risks that could lead to exceeding the budget? And the third point is returning on investment, ROI. This is a short form of return on investment, ROI. Will the cost of the project or decision provide a good return or value? And the last point that we know, cost benefit analyzing. How do the benefit of the project compare to the cost involved in the making building or small buildings? The next slide is determining design criteria. For in this we need to first we need to visit the site and analyze the climate and terrain and surrounding buildings. First these things we need to analyze when we make buildings, small buildings. And the second one is building code, which is the most important point in this all, that regulation and standard for construction. The third point is client requirement, what the client need. We always need to work according to the client, what they want and what they require. And the fourth point, which is the last point, budget concentrate, financial limitation for material and construction. We have to make our budget and we not close that budget, and this is the main point. Let's move to next slide. Assessing design load and safety factor. There are different loads in the making small buildings. The first one is dead load, second one is live load, and third one is wind load, and fourth one is seismic load. And as you know that dead load is that load like the permanent loads like pillars, columns, beams, and all of these. This is a dead load which is a permanent. The live loads are those live loads like living peoples in the building, or like that we can move, that are temporary loads like furnitures and chairs, tables, all of these are the live loads. The third one is wind load, which forces exerted by wind on the building. This is a wind load, which the load which you can see in the building. Oh, I'm sorry. Yeah, as you can see in the picture, the wind load, the wind exerted on the building, this is called a wind load. And the last one is the seismic load, which forces due to earthquake on the building, like the shaking of the building. It's called a seismic load. Let's move to next slide. Factors influencing design criteria selections, like seismic activities, wind exposure, snow load, and solar orientation. First one is seismic activity. Seismic zone influence design requirement, and there are different type like earthquake, volcanic activities. And in wind exposure, coastal areas require stronger structures where the wind is mostly occur. And the last one is snow load. Mountainous region require roof rainy for cement. And solar orientation, maximizing passive solar gain. Let's move to next slide. Key structural elements. First one is beam and columns, which support the building and support the weight of the roof and floors. And second one is walls, enclose the building and provide insulations. And the third one is roof structure, which protect the building from the elements like rain, wind, and all the other elements. And the fourth one is floor system, provides a solid and level base for the building, which we also called a foundation. Next one, foundation and substructures. There are different type of foundations. You can see shallow foundation and deep foundation. What is shallow foundation? Shallow foundation spread. In shallow foundation we have 2 points. First one is spread footing. A spread footing is a type of shallow foundation that spreads the load of a building over a large area. And the second point is strip foundation, a continuous strip of concrete used to support walls. It's common in residential buildings and is placed directly below load-bearing walls. And the second type of foundation is deep foundation. Deep foundation covers 2 foundations like pile foundation and pier foundation. What is pile foundation? It is a long slender columns like piles, which we call piles, and driven deep into the ground to transfer the load to deeper, more stable soil or rock layers. used in situation with a poor surface soil. And the second one is the pile foundation. Similar to pile foundation, piles are larger in diameter and typically used in situation where the depth of suitable soil or rock is shallow. The second point of this, now we have completed the foundation. Now the second one is substructure. The component of substructure is basement, plinth, and retaining walls. First one is basement, which covers walls, floor slab. Walls, basement walls provide vertical support to the superstructure and resist lateral earth pressure. They can be made of concrete, masonry, or other materials. And the second one is floor slab. The floor of the basement is a concrete slab that provide a stable and the level base. The second point is plinth. The plinth is a part of substructure between the ground level and the foundation. It serves as a transition between the foundation. The third point, which is the last point of the component of the substructure, the last point is retaining walls. Retaining walls are used in substructures to hold back soil and resist lateral pressure in situations where there are changes in ground elevation. The last point is conclusion of the all slides. The conclusion of this whole slide is the design of small building in New Zealand is a paramount importance as it conquers housing demand in the country and the climatic target of the state. Designer can always come up with function, sustainable and user-centered spaces that are efficient, comfortable and even environmental sustainable. And it play a role of deciding on the material to be used in a construction, the time factor and the most importantly the cost ensure that the structure developed are sustainable as well as cheaper to a build. Small building design in New Zealand also has strict requirements on safety and structures. And the design criteria and several significant structure parameters need to be chosen properly. Thus, it is possible to define that small buildings, if construction with a proper design, can be effective in the processes of sustainable development and facilitating the needs of people and providing solution for society. These all are the conclusion. This is the conclusion of the making small building design in New Zealand. Thank you. These all are the references from where you can see all the material that I have taken from. Thank you.
Okay, thank you so much, Jagdeep. Any questions?